In this example, we're going to prove that the max norm is a norm. So there's a couple of things that we need to prove here. We need to prove that we have for any vector x, that the max norm is greater than or equal to 0, and that it's equal to 0 if and only when x is a 0 vector. Okay, well, that's true when the max of the absolute value of the xi's is greater than or equal to 0. And because these xi's are absolute values, they're always greater than or equal to 0. This is always true. And then, of course, the max of the absolute value of the xi's equals 0 only when all xi's are equal to 0. And if all xi's are equal to 0, then x is the 0 vector. Okay, so the max norm is greater than or equal to 0 and equal to 0 only when x is the 0 vector. So part 1 done. We've been able to prove positive definiteness. Next, absolute homogeneity. We need to show that the infinity norm of alpha times some vector x is equal to the absolute value of alpha times the norm of vector x. Well, the infinity norm of alpha times vector x is equal to the max of the absolute value of alpha times each component in x, so each xi. Well, that maximum value is going to be equal to the absolute value of alpha times the absolute value of xi. Now, the alpha is just a scalar. It's the xi's that determine the maximum value. So this is really absolute value of alpha times the max of the xi's by absolute value. But this is the infinity norm for x. So the infinity norm for alpha times vector x is the absolute value of alpha times the infinity norm for x. Finally, the triangle inequality. So we need to show that the max of the sum of vector x plus vector y is less than or equal to the max norm for vector x plus the max norm for vector y. Okay, well, the max norm for x plus y is equal to the maximum value of the absolute value of xi plus yi. So we're looking at the largest absolute sum. But that's less than or equal to the maximum value, the maximum size of the largest component in x, plus the maximum size of the component in y. Right? That is, if I looked at x plus y, and I looked at the largest component in that sum, it would be less or equal to the largest component in x plus the largest component in y. In fact, they're only equal when vector x and vector y have their largest component in the same spot. So we're less than the max of x, max y, which is the infinity norm for x, plus the infinity norm for y. And so because all of the three pieces are satisfied, the infinity norm is in fact a norm.